Okay, we're in this world of matrices, and we define matrices by rows and columns. And we know, and we've done some multiplication, and we know that the number of columns in the first matrices must equal the number of rows in the second matrices. Number of columns to the number of rows. First matrices, number of columns. Second matrices, number of rows. Now, at the beginning of this chapter section, on page 179, we had some information about Lisa Leslie. And we have a spreadsheet here that shows how many baskets of which type, field goals, three-pointers, and free throws, that she scored over a four-season period, 2005, 6, 8, and 9. And then that information then has been displayed to us in matrices. And so matrix B here is the number of baskets. And matrices P is the point values for that type of basket. So a field goal is a two-pointer, three-pointer. Three-point field goal, of course, is 3 points, and a field goal is 1 point. And we're asked to find how many points, which season she scored the most points, and how many points did she score in that season. Now let's think, okay, so matrix B, in matrix B, I've got, let's see, how many rows? Well, I've got 3 rows, and I've got 4 columns. And then in matrix P, we've got 1 row and 3 columns. But if the number of columns in the first matrices has to equal the number of rows in the second matrices, then I can't multiply B times P. But what if I switch that around to where P, I got P, which is 1 row, 3 columns, and B is 3 rows, 4 columns, then my number of columns does in fact equal my number of rows, and I could put those in matrices and multiply them. And that, my friends, is what we're going to do. And so we're going to move over here to the calculator, because after multiplying square matrices, I think you will probably agree, if I can find an easier way to do that as opposed to doing it manually, I probably want to know how to do that. And so we're going to use this little simple example of a 1/3 matrix multiplied, where we're multiplying it times a 3/4 matrix. Well, that sounds pretty good to me. All right, hold on. All right, so we've got 2 matrices. We've got one that gives us the point value for the type of goal that is scored, a 2-pointer, a 3-pointer, and a free throw. And then we've got another matrices, which was matrices B, which gave us the number of baskets that were scored in a particular season, 2000. So column 1 was 2005, column 2 was 2006, column 3 was 2008, and column 4 was 2009. And if we multiply P, which was a 1-row, 3-column matrices, times B, which was a 3-row, 4-column matrices, then our number of columns to number of rows matches up so that we can multiply these. So let's go in here and let's enter our matrix and then see if we can't get this to multiply. So let's see, I'm going to go second matrix. No, that didn't do it. Let's clear second matrix. All right, so I need we'll edit this, and I need a I need a 1-row, 3-column matrix for the number of points scored. And so we got a 2-pointer, we got a 3-pointer, and we have a free throw. 2 points for a regular basket, 3 points for a 3-point shot, and a 1 point for a free throw. Okay, and now I'm going to go in here to my B matrix. I'm going to edit it, and we're going to set this up as a 3-row, 4-column matrix. So 1 row, 3 columns, 3 rows, 4 columns. Okay, I think that's looking pretty good. And we're going to enter this information for the number of years. So for the number of field goals, in 2005, she had 197. 2006, there was 249. 2008, there was 184. And you can see this on page 179. And let's see, 2009 was 143. And then for 3-point goals in 2005, there was 7. 2006, there was 8. 2008, there were 4. In 2009, there was 1. And then her number of free throws in this 3rd row. Column 1 is 2005, there's 102. And then column 2, there's 158. And column 3 is 117. And column 4, there was 65. So I think I got all my data right. 197, 249, 184, 143, 7, 8, 4, and 1, 102, 158, 117, 65. Okay. So now I just want to multiply my matrix A, which is what my matrix P was, my point values, a 1-row, 3-column matrix, by matrix B, my baskets, which is a 3-row, 4-column matrix. And getting those columns and rows matched up allows me to multiply those. So let's see, let's quit here. We'll go to the math screen, and I want to multiply. So I'm going to go second matrix, and I'm going to choose matrix A. That's the one that's got 3 columns. And I want to multiply it by matrix B, which has 3 rows. I've got to get down here to B. Okay, hopefully this works. Ah, Shazam. So there I've got now a 1-column, 4-row matrix, which would make sense. And let's see, so then in 2005, she scored 517 points. In 2006, it was 680. In 2008, it was 497. And in 2009, she scored 354 points. And so she scored, her highest scored season was in 2006, and she scored 680 points. Now we're going to look at the commutative property and the distributive property of multiplying matrices here in a moment. There's some interesting properties when we multiply matrices there, and believe me, you're going to want to use this calculator in order to do it.